Checking ourselves before we do some assessment type stuff. So we're going to talk about the very first assessment, and that's basically covering your understanding of position time graphs and all the information you can gather off of that. So we're going to focus on two key questions here, and based on those two questions, you should basically see if you understand everything that has to do with a position time graph. So it says, draw the correct velocity time graph based on the position time graph shown. That's this guy here. And then describe the velocity of the object at the 3-second mark based on the xt graph. And I should also write and describe its position. Should do both those things. All right, so do both those things. All right, so that's your mission. All right, so you're gonna, on your own sheet of paper, whatever, you're gonna try and answer these two questions, and you're gonna come back. I'll show you the answer. If you got it right, kudos to you. You're awesome. You're ready to go. If you got it wrong, then we'll walk through a step-by-step of how did I get here. All right, so pause the video and come back and see what you can do. All right. So here we go. Here's your answer in 3, 2, 1. No peeking. So look it over. Here's what your velocity time graph should look like. All right, this is the line. There's the line you started with. This is the new velocity time. And this is the answer you should get. All right. And if you got it, awesome. If not, then I'm going to start talking about how do we get here. All right, so let's jump back to the future. Velocity time graph based on the position time graph shown. So when it says a velocity time graph, remember velocity is defined as the slope of a position time graph. All right, so really this says, hey, can you draw what the slopes are? And so you have to ask yourself, how many slopes do I see? Well, the answer is I only see one slope. And then you have to ask yourself, what type of slope is that? Because there's no number of numbers on here, so I can't calculate it. So you have to ask myself, is it positive? Is it negative? Is it zero? Since we are going up and to the right, we have a positive slope. So what that means is I have one constant positive velocity because I have one constant positive slope. So anywhere in this positive world, I can draw one flat line. The fact it crosses through the origin is totally irrelevant here. No one cares because the question was to draw the velocity, and the velocity only cares about slope. It just cares what does this line look like, not where it is, not where it's going, just what does it look like. All right, so that's the answer to the first question. All right, to answer the second question, we are going to ask ourselves, okay, describe the velocity of the object at 3-second mark. Well, like I said, you ask yourself, what's the slope? The slope is constant. Therefore, we have a constant slope. Therefore, our velocity is constant. The slope is positive, so our velocity is positive. And so we have a positive constant velocity. So again, you just want to put that into words. So right here we got a positive constant velocity. All right, and then finally it says describe the position. When we're talking about position, well, this is a position time graph. I just read this thing directly. So I ask myself, well, at 3 seconds, where is it? So 3 seconds, I go back over. I'm like, well, where am I? Oh, I'm at 0. I'm at the origin. So therefore we go object is at the origin. So key things to remember when asked to create a velocity time graph or just asked anything about velocity in general, all you care about is the slope of that line. And then if you're asked anything about, positions, you read this graph directly. Those are the two keys to success. All right? Best of luck on you. Hope that helps.